Welcome back, everybody. So we're already on tutorial 6 of our Learning to Use Geogebra series. I know it's hard to believe, but I guess time really does fly when you're having fun. And so what we want to learn about today is we want to learn about the Theorem of Thales. So we want to be in geometry perspective, which I'm already in, and for options, we want to label new points only. So the first thing that you want to do is you want to create a line segment. This can be any old line segment that you want. And so once you've created your line segment, we're going to use a new tool. We're going to do semicircle through 2 points. So start with point A and connect to point B. And so that'll create a semicircle. Next thing that we want to do is we want to create an arbitrary point on that semicircle. So make sure your semicircle is bold and click to create the point. Doesn't matter where it is. And then just drag it around just to make sure that it's created properly and it's always stays on the semicircle. And then what we're going to do is we're going to create a triangle with these 3 points using the polygon tool. So we'll start with point A, we'll go counterclockwise, and we'll create a triangle. Now what we want to do is we want to discover a little bit about the properties of this triangle. So what we want to do is we want to look at the angles. So what we notice about the angles as we move around point C is that the angle ACB is always 90 degrees. So it doesn't matter where we move point C along the semicircle, the alpha and beta angles change, but the angle gamma is always 90 degrees. And that is the Theorem of Thales. It says if the base of our triangle goes across the diameter of a circle, then that opposite angle will always be 90 degrees. So that's pretty interesting. So what we want to do now is we want to try to discover a little bit about why this is true. And so what we want to do next is let's go ahead and create a new point at the midpoint of our base of our triangle, or the hypotenuse if you will. And so what we want to do now is we want to create a line segment that goes from point D to point C. So now what do we notice there? So now we've created 2 new triangles, one on the left, one on the right of our line DC. And so what are the properties of these triangles? Well, look, as we go from D to A, that's the radius of our circle. And D to C is also a radius of our circle. And D to B is a radius of our circle. So what we've got here is we've got 2 isosceles triangles. So triangle ADC is isosceles, and triangle BDC is also isosceles. So the opposite angles to the equal sides here and here for the left triangle are going to be equal. That means that this angle should be 43.32 degrees to match alpha. And so just to confirm that's the case, let's go ahead and create the angle ACD. Let's move it down here a little bit so we can see it. And sure enough, it is equal to alpha, 43.32 degrees. So we can do the same thing with the other triangle. And get that angle. And since that triangle is also isosceles, the opposite angles to the equal sides are going to be equal as well. So now what can we do? So we've got one big triangle that sits inside this circle. And so now we know that this angle is alpha, this angle is beta, this angle ACB is alpha plus beta. So what we have is 2 alpha plus 2 beta equals the sum of the angles of the triangle, which is 180 degrees. So if we factor out a 2, we have 2 times alpha plus beta is equal to 180 degrees. We divide both sides by 2, and we have alpha plus beta is equal to 90 degrees. Well, alpha plus beta is just our original angle, ACB, and thus we've got a proof of the Theorem of Thales. So I hope you enjoyed this one. I think it was a lot of fun, and I'll see you guys again next time.